Hi everyone, hope you are doing well. Today we are going to learn about Amazon EC2 Spot blueprints. Before we go further, let me introduce about myself. My name is Swapnil Pawar. I'm working as a software architect with AGS Digital. I'm holding few AWS certifications, a developer associate, solution architect associate, cloud practitioner, and few certifications are lined up in this coming year. I'm also active on LinkedIn. Feel free to reach out to me on LinkedIn. You can see my LinkedIn handler down below. So today we are going to learn about Amazon EC2 Spot blueprints and what Spot blueprints are and how you can make use of Spot blueprints for your workload. So what our today's agenda will be? What is Spot blueprints? How you can get started with Spot blueprints? Spot blueprints, template generation with infrastructure as a code tool like CloudFormation or Terraform. And we're going to see some demonstration of a Spot blueprint. Now, if you see, if you remember in the last video, we learned about what are the Spot instances, how you can create or request Spot instances, how the Spot instances work, and how it is cheaper than the on-demand instances. So you learn that. Now let's take a further step and understand what Spot blueprints are. Now, Spot blueprints is basically infrastructure as a code template generator that makes it easy to start using Spot instances. It saves our time and leveraging the steep savings and scale that Spot offers for interruptible workloads. Unlike traditional wizards, like what you need to do is you need to read a lot of documentation. You need to go to the console and a lot of other places to make use of the Spot instances. But Spot blueprints actually generates a custom infrastructure as a code in real time or within each step, so you can easily understand the details of the configuration that you're configuring. The best thing is Spot blueprints makes keeping us with the latest and greatest feature. For example, like capacity optimized allocation strategy and capacity rebalancing for EC2 auto scaling easy. Since AWS takes care of the Spot blueprints, and AWS keeps updated to support the new features, and they become easily available with us. Now, as I said earlier, right? In order to use the Spot instances, you have to look at the documentation, but comparatively to Spot instances, Spot blueprints actually gives us a jump start by providing simple to follow instructions on the management console itself. And it takes your workload requirements and it outputs an infrastructure as a code in CloudFormation or either in Terraform format. This is just a recap of from the last video. So EC2 Spot integration is possible with a lot of AWS different services like Elastic Beanstalk, EMR, Elastic Kubernetes service, Elastic Container service, machine learning services like SageMaker, AWS Fargate, serverless container running uh, platform. We have AWS batch processing platform. We have auto scaling. So Spot instances has its own ecosystem where it integrates seamlessly with the AWS services and provide you greater benefits for your workload. Let's go over the Spot features again. It will help you understand more. This is one of the feature that it provides a rebalance recommendation for Spot instances. Like it triggers a signal that is sent when a Spot instance is at elevated risk of interruption. Mixed instances policy, like the auto scaling group configuration, enhance availability by deploying different instance type. It's not like you have to choose a same instance family, but a different instance family gives different performance and the variant that you can run in a multiple availability zones. Capacity rebalancing for auto scaling, basically for proactively managing the Spot instance lifecycle in an auto scaling group. Capacity optimized allocation strategy, This will help you to find the most optimal spare capacity for your workload rather than you selecting C5, whether Spot instead recommends that instead of C5 X large, we can go with the M5 X large. With that, you can also get your work done. And one of the open source tool that we looked at in the last video is Amazon EC2 Instance Selector, which is the CLI tool that will help you uh, to uh, to find out the instance type for your workload, based on the virtual CPU and the memory that we can provide. Now, how to get started with Spot blueprints? It's very easy. We can get started with Spot instances very easily. As I said, it's a simple to follow infrastructure as a code generator. What it asks for is it asks for your workload requirements. And we're going to see the demonstration in the coming slides, but it asks for the workload requirement, like what kind of virtual CPU you want, what kind of memory you want. And, based on your requirement, it will output the infrastructure as a code in CloudFormation and Terraform. And obviously, that template can be modified further as per your infrastructure. So blueprints basically guides you through each Spot best practices and applies them automatically. And when you add your workload requirement and when you see the infrastructure as a code template gets generated, you can actually download it in Terraform or the CloudFormation format, which you can customize it further before being deployed into different production environments. So you can, in your workload environment, you can actually if you use your existing IAM roles, you can configure the network configuration, like which VPC you want to use, the subnets basically. So you're gonna see a lot more things, in the demonstration. And as I mentioned earlier, Spot instances are obviously a great fit for fault tolerant applications like batch processing, big data ETL, Apache Spark, and it also great fit for running fault tolerant applications like container orchestration tool that we saw earlier, integration with ECS and EKS and all those things. Now, Spot blueprints, workload templates. So AWS has created a 4 different predefined workload template for us to take advantage of the Spot instances. So currently, there are 4 different type of workloads available, namely Amazon EMR, Amazon EC2 auto scaling, AWS Batch, and Amazon Elastic Kubernetes Service. But what if you have, different requirement that you need to leverage a different Spot blueprint, and you don't see it in the AWS console? So, how do you go further in that? So, let's go over to the AWS console and let's see what you can do if you don't see any blueprint that that don't fit to your workload which currently has. So let's head over to the AWS console. So here we are in AWS console. Now, as I said, if you don't see the Spot blueprint, uh, you know that needs your workload, what you can do is you can go to the services, compute, and EC2 service. On the left hand side, click on the Spot request menu, and once you land it to the Spot request page, on top you can see the Spot blueprints. So click on the Spot blueprints, and here this is the Spot blueprint screen, and here under the blueprints section there is a link and there is a text mentioned, don't see a blueprint you need. Then you can click on it, a pop-up will open, and you can mention the description of your requirement of your Spot blueprint that you need. and you submit it, and AWS will further processes from there, and you will hear you will hear from them. So that's how you wanna raise a request to the AWS if you have specific blueprint requirement. So now let's head back to our presentation. Let's go further and understand the different workloads that Spot Blueprints provides in a template form. Now, as we see in the previous, there are four different workloads. Okay, the first one is Amazon EKS with EC2 Spot instance. EKS is basically a Elastic Kubernetes service that you can run your container workloads. So with EC2 Spot instance, it enables you to take advantage of steep savings, and you can scale that Spot instance for interruptible workloads running on your EKS cluster. It also allows you to create manage node group, which enhances the availability of your applications on Spot. So Amazon EKS manage node group, with Spot capacity, will enhance the node group experience, the managed node group experience with ease to provision and manage the EC2 Spot instances. EKS managed node groups launch an auto scaling group with Spot best practices and handle Spot instance interruption automatically. Now, when creating a managed node group in EKS, simply set the capacity type as Spot and the multiple instance type that meet your requirement. Next, we have Amazon EMR with Spot instances. Now, EMR basically it's a managed cluster platform that simplifies running with big data platforms or frameworks rather, such as Apache Hadoop and Apache Spark to process and analyze a vast amount of data. So Amazon ECR also will give you the Amazon EMR with Spot instances allow you to take advantage of that unused capacity which you needed for analyzing vast amount of data. So so Amazon EMR has launched a new feature called Instance Fleet that will help you to provision vast variety of provisioning options. So you specify the target capacity for on-demand instances or Spot instances within each fleet. And when you launch the cluster, EMR provisions instances until the targets are fulfilled. Now, EC2 Spot instances with EMR auto scaling feature will allow you to dynamically scale your cluster in and out based on your cluster usage and other job related metrics. And this is very important point. You can specify a maximum of 5 Amazon EC2 instance type per fleet for Amazon EMR to use when fulfilling the targets, or a maximum of 30 Amazon EC2 instance types per fleet when you create a cluster, basically using CLI or API. And you can also leverage allocation strategy for your on-demand and leveraging Spot instances. So as I mentioned earlier, Spot instances leverage this capacity optimized allocation strategy, which allows instances from most available instance pools and lowers the chance of interruption. And with that strategy, it will help you to run your workload very appropriately and have a higher cost of and that will lower uh, your chances of interruptions basically. The next workload we have is AWS Batch with EC2 Spot. What is AWS Batch? So AWS Batch, to give you a little background of AWS Batch, AWS Batch is a fully managed cloud native batch scheduler. It manages the queuing and scheduling of your batch jobs and resources required to run your jobs. And one of the benefits, and it's actually a strength of AWS Batch, is the ability to manage instance provisioning as your workload requirements and budget needs change. So batch take advantage of broad base of compute types. So to give you an example, you can launch compute-based instances and memory instances that can handle different workloads without worrying about building a cluster to meet peak needs. So there are three different allocation strategies you can choose when creating AWS batch workload. The first one is spot capacity optimized. The second one is best fit progressive, and the last one is best fit. Now, what is spot capacity optimized basically? So, when you select the spot capacity optimized, batch will select one or more instance type that are large enough to meet the requirement of the jobs in the queue, with a preference of instance type that are less likely to be interrupted. To give you kind of an example, so let's say you are running a simulation workload in your AWS batch, and your workload is spot appropriate, and so you want to take advantage of the steep savings, that you get from the spot. However, you also want to minimize your interruption rate. Okay, and so your instances can run across multiple instance type and multiple availability zones. So when creating your spot capacity optimized in AWS batch, that will allows batch to choose from among M, C, and R instance families. So it will automatically uh, select uh, instances from the allowed instance types. The best fit progressive basically. Now, AWS Batch selects additional instance types that are large enough to meet the requirement of the job in the queue. Uh, it has preference for instance type with lower cost of each unit CPU. So that's the best fit progressive. Uh, To give you an example, imagine you have a time sensitive machine learning workload. This is very compute intensive. I mean, you are launching C5 instances because you know that those have a preferable virtual CPU memory ratio for your jobs. But however, you know that instead of C5, M5 instances can also run your workload preferably well, so that you are happy to take the advantage of the spot prices. So, with the best field progressive strategy, uh, uh, what it will do is it will allows you to let AWS batch choose the best fit instance for your workload, and based on what vCPU and the memory requirement that you provide. And the last allocation strategy is best fit. What best fit defines is you select an instance type that best fits the needs of the job with preference for a lowest cost instance type. And let's say if additional instances of the selected instance type, let's say you selected M5 and M5 additional capacity is not available, or AWS batch waits for that additional instances to be available. And obviously, with this strategy, it keeps your cost lower, but you will find a limitation in scaling because you need to wait um, until the next available instances, next additional instances are available for you, uh, you know, uh, uh, to run basically. So let's go over to the AWS console and see how with AWS batch you can, integrate spot instances for your workload. So let's head it toward AWS console. So here we are in AWS console. So what I'm going to do is I'm not going to show you with the Spot blueprints method. What I'm going to do is I'm going to show you the normal way how you can uh, leverage Spot instances with the AWS batch workload. So, you can search for batch, which is, the first service up here. Click on it. And on the left hand side, select the compute environments because you need the environment to run your workloads. So in the compute environments, click on create, and there are two different environment types. So basically, obviously, we are going with the manage because that's how we're gonna leverage the Spot instances. So once you select the manage, you enter the environment name, and under the instance configuration section, we can see a provisioning model. And there are four different provisioning models that available with AWS Batch. One is Fargate Spot, on demand, and Spot instances. And if you select the Spot instance, you can see the configuration or the input that we need to provide it in order to uh, select the best workload for our processing. If you see the allocation strategy, like we saw, there are three: best fit, progressive, and Spot capacity. So if you see the best fit and best fit progressive, it will automatically select for you and the instance type that you wanted. You want optimal, or if on C5, C4, anything you wanted. The desired virtual CPU that you want, maximum and minimum that you wanted. So remember, the desired virtual CPU should be uh, between minimum and maximum CPU value. Okay, you cannot exceed the desired CPU value than the maximum CPU value. For example, if I put 512, you might get an error, right? So keep in keep in mind. And the networking, you can select the existing network, or you can obviously create a new VPC for the special workloads and select the subnet where you want to launch the instances basically, and you can create the compute environment. So that's how you're gonna leverage AWS batch with Spot instances, for your batch processing workloads. So hope you understand how how you can leverage EC2 Spot instance with AWS batch, EMR, and Kubernetes services. So let's head back to our presentation. And this is the last workload template type we have, auto scaling with EC2 Spot. Now, you must be knowing, right, what is auto scaling? So auto scaling helps you ensure that you have the correct number of Amazon EC2 instances available to handle the load for your application. So basically, you create an auto scaling group. And obviously, auto scaling provides you with a feature like health check replacements, scaling policies, and both maintaining the number of instances in auto scaling group. Now, when adapting EC2 Spot instances, our recommendation is to consider auto scaling group since offers benefits like scaling, lifecycle hooks, rebalance recommendation, warm pools, predictive scaling, and many more functionalities that we can leverage. So, if you remember when you work with auto scaling group, you used to create a launch template that help you provision capacity using both Spot instances and on-demand instances to achieve desired scale, performance, and cost optimization. Here also, in EC2 Spot with auto scaling with capacity optimized allocation strategy has been selected automatically and is what recommended for nearly all applications because it selects the right uh, workload, right instance type for your workload. Obviously, both on-demand and Spot instances will be mixed in the auto-scaling group, and this is not a mixed instances policy. And if your application is state-led, that means uh, uh, that your if it's okay if if you lost the data and fault tolerant, and can handle an instance being terminated, mostly Spot instances will be used, uh, because that Spot instance will be used to process data. Even if you lose it, it's gonna uh, does not hamper anything. So you can leverage a small demand of on-demand instances with scaling feature of with Spot instances that will give you the most benefit. Now, as I said, EC2 auto scaling has a feature called capacity rebalancing that we saw earlier. And when we enable that, obviously, you know, uh, whenever the Spot instance in your auto scaling group is at elevated risk of interruption, it will proactively attempt to launch a replacement Spot instance. So there are a lot of features that are available with EC2 Spot instances. Auto scaling has uh, you know a different feature that you can leverage it, supporting multiple launch templates, instance weight, okay, and a lot of different things. So let's head over to the AWS console again, and now we're gonna see how you can use actually Spot blueprints for one of the workload templates that we saw earlier with EKS, AWS Batch, EMR, and the auto scaling. So let's head over to the AWS console and let's see how you can leverage Spot blueprints for auto scaling. So we are back in AWS console. So uh, click on the Amazon EC2, go to the menu Spot request, click on the Spot blueprints. And as we see earlier, there are 4 different workloads currently available, workload templates currently available in Spot blueprints. You're going to see it EC2 auto scaling. Click on the radio button, and if you scroll down, you will get small information about it. Uh, if you just need a template, you can directly download it from here without any modification, and we can modify it locally in both the infrastructure as a tool format, whether in CloudFormation or Terraform. Okay? And or if you want to modify it a little further, you can click on the radio button and click on a button configure blueprint. As soon as you configure blueprint, you will land it with a screen where are the different uh, steps that you want to configure. So there are total 5 steps that you want to configure. So blueprint name, okay, you can give it any blueprint name as per your naming strategy. In the permission section, you want to make sure that the instance permission to access repository. So if you have existing role, you can select it. If you do not have it, uh, this will be automatically created for you. Okay? And if you expand this code snippet preview box, you will see 2 different tabs, CloudFormation and Terraform. So this code is automatically generated for you. And if you look at it, this is an instance profile, and that will be created. And one is the IAM role. See the type. So this 2 type. One is one instance profile. So with this, create a new role. If you will also get information here that if deployed, uh, the configuration from the step 1 will create 2 resources. It will create 1 role and 1 instance profile. So you will get all the information here. You do not need to change anything. It's a simple, just like the follow up. Just follow it, and you will get it. So once we done with the step 1, just click on next. Now here we're gonna configure our network. You will also see the information that you needed. If you do not have existing VPC, you can create a VPC with public subnets. So What it will do is Spot blueprints will follow the Spot best practice automatically, and it will use all subnets across all availability zones, which provides you with spot capacity pools, and that will increase the possibility for EC2 to find and provision required capacity. If you already have existing VPC, you can select it. Now this is the default VPC I have, and as soon as you select it, by default all subnets will be selected, and that's how the spot best practice. But if you remove one of the subnet, it will give you warning saying that spot best practice not followed. So make sure you add all the subnets. The reason, because it will increase the possibility for EC2 from the spot capacity pools. And again, if you expand the code snippet preview, yeah, since I have selected existing VPC, no code will be generated. But if you click on create a VPC with public subnets, it will automatically generate a template, and it will generate all the resources which is required, like internet gateway, which is required. We need a gateway attachment for that VPC. We need a VPC. We need a route table. Right? Then we need a subnet route table association. So all these required resources will be created for you when you select the create a VPC with public subnets. The destination CIDR, so all this will be provided for you, and as well as the Terraform. And it also shows that if deployed this template, it will create one VPC. Total 13 resources will be created, like 4 subnets. Why 4 subnets? Because as per the Spot best practice, in each availability zone, it will be deployed. Okay, obviously 4 different subnet table association, one route table, internet gateway, gateway attachment, all those things will be created. Now, once you configure the network, let's move on to the next step. Now here, the compute environment. In every workload template, you will get an option to create a compute environment. And the first one is auto scaling size. And when you run your workload using EC2 instances or Spot instances, you want to make sure that you should have the minimum capacity of 1 or whichever as per your workload. Basically, so even though there is a termination, a minimum of 1 instance will always be running in your environment. Maximum capacity, as your workload increases, how many instances that should be launched based on the utilization, let's say 10. And what would be the desired capacity? So, as I said it earlier, desired capacity should be between minimum and maximum capacity. If you try to choose the desired capacity, and if you try to go next, it will throw an error saying desired capacity must be between minimum and maximum capacity. So if you say 4, auto scaling will automatically try to make sure that minimum of 1 and desired capacity should be met. This is the Spot configuration, like instance configuration. What type of EC2 instance family you want to choose for your workload. Now, here also, as per the Spot best practices, you can select different families, generation, and sizes. As we say, different instance type family will give you much more flexibility. So you can also minimum virtual CPU that you want, and what kind of memory you want. So you can select it, and the allocation strategy that we saw, right, capacity optimized, will be automatically applied for you, and that will help you provision instances from the optimal pools, for your capacity. And if you expand this instance details, you can get a list of all the instance type that based on the value that you provided in minimum compute ratio and the virtual CPU per instance. So instances will be provisioned from this instance type. And similarly, code is available for us and the information that what resources will be deployed. Okay. So once you have all this configuration, click on next. Now this is the scaling policy for the load balancer. And for example, if you want to add capacity or remove capacity to your autoscaler, you can select the metric type, okay, average CPU utilization or the number or the average network in and out of the uh, network, how many in bytes. So let's say if average CPU utilization goes over 70%, auto scaling policy will be kicked in and additional instances will be added to your load and to your capacity or the load balancer. So if you want to disable it, this is completely optional. Now, load balancer. Now, if you remember, there are different types of load balancers we have. We have network load balancer, application load balancer, classic load balancer. But Spot, a blueprint for auto scaling, it will only support application load balancer. Okay. And there are two different schemes available, whether you want internet facing load balancer or internal load balancer. Internet facing, all the traffic coming from the client will head it to load balancer URI. Internal, if there are different tiers like web tier, application tier, and database tier, if you want to scale traffic from web tier to application tier, you can leverage load balancer, and route the request with the private IP addresses and with port you want request to route through, whether it's 443 or port number 80. I want to keep internet facing, and again the template is generated for you, and it will create a listener, target group, and load balancer for you. So once you done configuration, click on next. Now this is the last step. Once all the steps are completed, here you can get the blueprint code, and this blueprint code contains a combination of all the 4 steps that you configured earlier. Okay, this is a complete CloudFormation template that you can leverage. You can download this in whichever format you want it, whether it's a Terraform or CloudFormation. You can download it. If I click on download, it will download it. As I said, you can configure it as per your requirement and utilize it in different environments. Here you can see Spot instances, best practices summary. And the resource summary, basically what is going to be created with this CloudFormation template. So you get the whole information, what is this creating, what values you need to provide basically, and everything will be dependencies and everything will be created for you. And once you click on the deploy CloudFormation, it will launch CloudFormation template in CloudFormation, and so let's deploy this. Or either you can also, what you can do is you can also copy this URL, go to the CloudFormation menu, or also you can click in CloudFormation from here. So we click on deploy CloudFormation, it will open a new tab opening CloudFormation, and paste the copied URL, click on next, and if you see here, all the parameters are predefined, what type of instance you wanted. So based on the configuration that you provided, it is launching 8 different types of Spot instances. right? M3, M4, M5, and R3, and different one. This is the AMI. This Amazon Linux 2 AMI will be launched, and just like how you launch the template, you can give the stack name and click on next. I'm not going to launch the template. Auto scaling EC2 Spot. Just click on next, just like this. I'm going next, and you can acknowledge it, and you can create the stack. So that's how you're gonna launch the auto scaling group using the Spot blueprints. Hope you got an understanding how you can leverage Spot blueprints, with the minimal steps. It's a simple to follow approach. Okay? Now let's head back to our presentation and see the Spot blueprints best practices. Spot blueprints best practices. So Spot blueprints provides flexibility to run a workload on multiple EC2 instance type. The configuration that you saw earlier, multiple instance families are selected for us based on the configuration that we have provided and different availability zones. It takes high-level Spot best practices like availability zone flexibility and applies them to a workload compute requirement. It run workloads that are interruption tolerant, meaning interruptible at both the individual instance level and overall application level. Also, ability to implement graceful interruption handling, load balancer connection draining, automatic job retries, and container draining and rescheduling. So these are the features that you can leverage with Spot blueprints. Hope you understood what Spot blueprints are and how you can leverage, to run your workloads on EC2 compute environment. Thank you for joining me today. Hope you learned about it. Feel free to send me a feedback. How did you like it? Again, thank you so much. See you in the next video.